Okay, let's turn the robot on. It's got an initialization sequence.
Ready.
Has a speaker rather than a piezo buzzer.
Left eye. Right eye. Right eye.
See if I can get both of them on.
Right eye. Both eyes.
Now the sound detection, it's 2 levels. Whoo! There's the lower one, flashes the red, does the motors. Whoo! The higher one just flashes the blues. Whoo! But increments a counter. Whoo! And after 3 times, it turns the sound on, toggles the sound on and off. Whoo!
Sound off.
You can see the response is a lot faster when we don't actually play messages. Okay, let's turn the sound back on. Whoo! Whoo! Whoo!
Sound on.
Now here's what I think's the best part. It has a, if it's not getting any light or sound input, it increments a, what I'm calling a nag timer, and after about 12 to 14 seconds it picks, randomly picks one of 2 different nag messages.
Talk to me.
The other message is need light. Okay, the construction, let's turn this off. I've got the 8 LEDs on the front, 2 photocells, a speaker, and a microphone. I've got 2 breadboards on the back. That was very handy for getting this SparkFun voice recorder board on there. It requires it has 8 inputs, and it requires a single low on one of those. I do that using a shift register, a 74595 serial in parallel out a shift register to generate a single low. There's also a shift register up here to generate to minimize IOs for driving 8 LEDs, and it's got also has a resistor pack in there for the current limiting. Here's the, let's see, there's the on-off switch, there's the regulator, here's the quad amp for the Wheatstone bridges and the microphone, here's the M430 2553 chip. While programming it, I had that launch pad hanging in here and wired up to the breadboard, but I wanted to see if I could get a standalone chip to work, and it just needed a pull-up on the restart pin. I also put a battery holder on here just to make it easy, and screwed the whole thing together. That was actually really hard to countersink some of these holes without wiping out the breadboard.